Today's hydraulic engineers. Water is a lifeless material, but through living organisms, it becomes a unique living force. Every civilization was born through the nurturing of water. The scenic mountains and waters that human existence relies on needs appropriate protection and utilization. Water conservation engineering in the 21st century is committed to the principles of caring for water and existing closely with water, preventing water disasters due to environmental changes, and at the same time creating sustainable water resources, and encouraging harmonious development between man and nature. This is the primary mission of today's water conservationists. Looking up to the stars, comprehensive geological survey. Taiwan is located along the western edge of the North Pacific Ocean, an area adversely affected by the ravages of typhoons. Typhoon onslaughts during the summer and fall, and with the fluctuating monsoon winds in the spring, droughts can easily arise. Plus, due to Taiwan's geography, its rivers are short and steep. When the rains come, the water quickly flows downstream, which easily causes flooding in mid and downstream areas, creating a stern challenge to the water environment. In recent years, with global warming, the global climate has changed, creating a severe water imbalance. Overdevelopment from humans has caused the soil to lose its ability to respond, adding to the problem of climate change, and lashing the entire world with dramatic attacks and disaster. For Taiwan, it too encounters this global challenge. The accumulated rainfall during recent typhoons have reached new highs when compared with historic benchmarks, creating severe damage and creating a phenomena of disaster whether it rains or not. These include 1998, Typhoon Zeb and Babs hit northern Taiwan, separately causing severe flooding to Chidu in Geelong and Taipei County's Shiger. 2000, Typhoon Changsan brought heavy rains, which flooded the Geelong River. The water leaked in through open areas in the uncompleted construction, inundating the area. 2001, Typhoon Nari weaved back and forth and delayed in the area for a long time, leaving pumping stations unable to keep up with the floodwaters, leaving many areas of Taipei submerged, and the Taipei MRT was inoperable for 2 months. 2004, Typhoon Mindul brought flood and landslides on July 2nd, and creating record-setting agricultural damage in central and southern Taiwan. Smart flood control, working together. Taiwan's natural water conservation conditions are not ideal, combined with factors such as climate change. Therefore, water conservation and flood control takes on added importance. Under the direction of the Executive Yuan, the Disaster Prevention Commission and Professional Consultative Commission jointly formed the Central Disaster Response Center, which collects information from relevant government agencies to jointly establish emergency response systems and link emergency response centers with the local level. From the central government to local governments, a complete water conservation and flood control system is formed. Of this, the Ministry of Economic Affairs is in charge of the flood and disaster relief agencies. It is responsible for commanding relevant administrative agencies and implementing flood and disaster control measures and emergency response and post-disaster reconstruction jobs. Therefore, the Water Resources Agency was established under the Ministry of Economic Affairs to coordinate all water control agencies. Under it are 1st through 10th River Management Offices and Water Resources Office, the Danshui Flood Control Command Center, Choshui Stream Information Center, Taiwan Power Company, Running Water Business Team, and other units. Plus, the Water Resource Agency's Water Resource Control Center enhances disaster controls, emergency responses when a disaster occurs, and post-disaster reconstruction measures, to effectively implement flood prevention inspections and plays an important role in the overall disaster control system. Another important disaster prevention program of the Water Resources Agency is running the Choshui Stream Flood Warning System. And with the high concentration of agriculture in the Choshui's downstream, the flood warning system not only reduces flooding damage, but also helps decrease the impact of agricultural irrigation and ecosystem imbalances, and thereby protects the lives and livelihood of humans. From the central government to the local government, a sound disaster prevention system is formed, jointly handling the unforeseen damage of typhoons' torrential rains. The concrete disaster control measures of the Water Resource Agency can be divided as follows: proactive reconstruction and monitoring. The proactive reconstruction system is directed at areas where disaster easily occurs. After comprehensive evaluation and diagnosis, water conservation and flood control programs are promoted, such as Taipei Flood Control Project, which is a good example of a water control policy that utilizes discharge and damming. Flood control must begin from upstream. Reservoirs not only have the function of storing water, but can also retain flood water. Therefore, the Feitsui and Sherman reservoirs in the Taipei area not only bring residents the convenience of water, but also improve their safety. Plus, to carry out flood discharging and diverting policy, the Yuanshansu Diversion Tunnel under the Geelong River Improvement Project is designed to enhance the safety standard of the Geelong River, which is the most possible to flood. This tunnel diverts the torrential flooding waters of the Geelong River to the Eastern Sea, helping to reduce midstream water levels and prevent the river from overflowing its dikes. The areas that benefit from this renovation include all of Taipei and Geelong. The key project at the WRA is the Geelong River Improvement Project, with a budget of 31.6 billion NT dollars. Such a large and urgent construction requires a special financial regulation and great teamwork between the central and local government. Through adopting the concept of treating the river as a whole, renovating the river from the upstream, and extensively using ecological engineering method, the project has now reached a great achievement. In 2004, when the torrential rainfall on September 11th and Typhoon Nok 10 hit, the Yuanshansu Tunnel effectively lowered the peak water level, and only a 24-hectare area was flooded, 1% of that caused by Typhoon Nari. At the same time, the Erchong discharge channel was built to lower the flood levels of the Xindian and Dahan streams. For the damming policy, flood control levees and dikes that meet the 200-year frequency safety standard have been built along both sides of the stream,